Let's see the examples of the Thevenin. So this is a same circuit as we already done previously by using the nodal, superpositions, and source transformation. Let's start with the first step, which is remove RL. You have to set in mind that you have to produce or determine the values of V Thevenins and then the value of R Thevenins. So where is the RL? Previously, there is a RL which is 8 ohm here. So in the Thevenin equivalent circuit, the locations of the 8 ohm is here as a load. So therefore you need to find the I8 that flows through the RL. So RL will be the R load. After you get or determines the V Thevenin and R Thevenins, then you can find the I8 which flows through the RL 8 ohm. In step 2, you have to find the R Thevenin. So where is R Thevenin? So R Thevenin at the terminal A to B. How to find the R Thevenins? The first is you have to disconnect all source. As you can see that in this circuit it consists of the voltage source in here and then the current source in here. For the voltage source, you have to short circuit the voltage source and then open circuit the current source. So this is the circuits for finding the R Thevenin, which is you can see that the circuit only consists of R only. You already learned on how to simplify a complicated circuit by using a step that I already informed previously in the chapter 1. So first is you have to draw the circuit to the simplified circuit. So you have to detect or determine the nodes or the essential nodes for each of the elements. So I already select with the X is shown in the circuit. So this is the blue color. So it stands for the one node. And then here is another node. And then here is another node. You have to remember that the R Thevenin is from this side. So your eyes must be looking from this side, which is the terminal A, B. After you redraw it, so this is the circuits of the simplified circuit, and then you can see that sums of the resistor is in parallel and sums of the resistor is in series. So in order to solve the circuit, you have to use the series and parallel method. As we can see that the 4 ohms and the 2 ohm is in parallel because it's sharing the same node, which is the node X and node B. The resistor that share the same node is parallel. And then you need to parallel this resistor, and after you parallel the resistor, it will become series with the 4 ohm. And then after you determine the series resistor, and then it will be parallel with the 10 ohm resistor. This is the details of the calculation, which is you can see that the RXB is here. So the 4 parallel with 2 is equal to 4 over 3 ohm. And then for the RAB, you can see that the R 4 over 3 series with the 4 ohm, and then you have to parallel with the 10. You need to solve the series resistor 4 over 3 series with the 4 first, and then parallel with the 10 ohm, and then you can get the values of the R Thevenin's is 3.4x ohm. As for the step number 3, you have to find the V Thevenin's. As referred to the circuits, the V Thevenin's is in the middles or in between the loop 1 and the loop 2. So there are two choices in order to do the KVL. Either you can do a KVL equation at the left loop or at the right loop. And then the answer will be the same. There is two choices, either nodal or mesh analysis. So if nodal analysis, which is 2 node, you can see that 2 is minus 1, which is grounds, is equal to 1 node only, which is equal to the 1 KCL equation. If you trying to solve the equation or finding the voltage using the mesh analysis, which is consists of the two loops, which is 2 minus 1, which is super mesh, and then you have to plus with the 1 super mesh equations. So there will be 2 equation, which is 1 KVL, 1 super mesh equation. So the difference in between those two is time. So 1 equation versus 2 equations. So actually you can solve or determine the V Thevenin's with any methods or theorem that suitable for the circuit. So this is the methods for finding the Thevenin's using the nodal analysis, which is you have to determine the essential node. So this is how to determine the essential node. So which is we group the X to be only one group. So we mark with the V, and then for the next essential node, which is the bottoms of the circuit, so select this one as a ground, which is the polarities of the voltage will be 0. Now let's do the KCL at node 1. So for the first branch, you can see that you need to find the summations of current for each branch. So the total resistor of this branch is 14. So it means that V minus with 5 volt over 14. The total resistance value for this branch is 14 ohm. And then for the second branch, you can see that the current is at the opposite directions of your assumption, which is we assume that all the current is exit from the nodes. For the next branch, 4 minus 0 over 4, and then for the last branch, which is 2 ohm, V minus 0 over 2 ohm. And then for the second line, you need to group the values of V so that it will become like this line. After you solve the values of the KCL equation, you can get the V is equal to 4.09 volt. Now you need to find the currents I1 because it will affect the values of the V Thevenin's. Please remember that you have to find the Thevenin's, the V Thevenin's actions in the circuit. I already mentioned previously, you have a choice. Either you want to solve the left of the loop or the right of the loop. So I1's, the values of I1 is 4.09 minus with 5 over 14 is equal to minus 0.065 volt. And then V for the 4 ohm is 1 I1 times with 4, the values will be minus 0.26. So this is the values of 4 ohm voltage. And then by using the right loop, I choose the right loop here. Assume that the loop is in a clockwise, and you can see that I start with the Thevenins here. So this is the first equation, minus 4 Thevenin minus V4 ohm, and then plus with 4.09 ohm. You can see that the voltage loop is flowing from this direction until the end. Make sure that you are selecting a correct polarity for the 4 ohm, because we assume that the currents is exit the loop. So it means that the currents entering your resistor, 4 ohm resistor, and then the polarity will be plus and minus. And then for the 4.09 volt voltage, you can see that the voltage is from this nodes to the ground. So this one is 4.09, here is also 4.09, and then also here is 4.09 volt. And then from the KVL equation as stated in here, then you can find the Thevenin as shown in this equation, which is minus 4 V4 ohm plus with the 4.09. It means that minus 0.26 volt plus with 4.09 is equal to 4.3 volt. This is the solution if you are trying to find the Thevenins using the left loop here. You need to find the V10 ohm here, because by using the KVL, you can see that the Thevenins here, Thevenin plus Thevenins minus with 5, and then minus with V10 ohm. And then after you are determines each of the value which is here, put that into the KVL equation, and then you can get the answer for the Thevenin is 4.35, which is same as the previous slide. Therefore, it's important that you can choose either left or right loop. The answer will be the same as long as the KVL equation consists of Thevenin. So actually, you can choose either you want to use this loop, and then of course you can do also this loop, and then also this loop. Step number 4, this is the Thevenin equivalent circuit. You already find the Thevenin and the Thevenin. To insert the RL into the Thevenin equivalent circuit, you can see that this is the RL. Final step, after you include all the information, all the value as shown in this figure, and then you can do the KVL in the loop. So minus Thevenin plus with I x times with Thevenin plus with Ri equal to 0. And then the values of Ix will be 0.3789. So the value is same as the previous method or theorem that you already done previously.